Welcome everyone. So today we have an interesting problem. So what I've decided to do from now on is to start actually just doing as many problems as I can. So you guys can just go to the description and then you'll find an email where you can basically send me questions and then that you would like me to go through and actually help you guys with or answer for you guys. And then I can just look at those questions and then basically I'll be solving those questions. So I'll stop with the lecture series. So I was basically just giving off lectures, like full lectures on different chapters. So I'll stop a bit now, and I'll just focus on problems, and then I'll come back with the lecture series later on. I don't know when. But then I'll just do problems from now on for quite some time. All right, so please just go to the description, read what is there, find the email, send me an email from that. And then otherwise, you can also just send me on our social media, Facebook basically, will just mainly be on Facebook. Then I'll tell you whenever we have everything in other social media sites like Instagram or Twitter. Otherwise, you can just subscribe if you're enjoying our content. You can share it with your friends. Just make sure that you spread the word and everyone knows that they can get help, that we doing videos that can actually assist students. All right, so this problem is very interesting. There's a variety of ways I can actually ask this problem. I saw it some time back, and then I've recently asked it in a different version. I've made up different versions of this problem, but I just decided to ask the more straightforward way of it. There's a lot that I can do with this problem. So basically what they want here is the total kinetic energy of the system. So since there's a chord, so you have to assume a certain things. You have to first assume that the chord, which is between the pulleys, so it's the same chord basically. This chord is going over this pulley. So I was lazy to write the whole question, so I'm waiting it and everything else. So I just decided to just put it like this and then just explain it here. So you have the chord that is going over the pulley, and just assume that it's actually connected at 90 degrees to the blocks, meaning that this is 90 degrees. It may not seem like that. Otherwise, if it's at an angle, it's going to give us more problems. So just assume that is at 90 degrees to each block. And then you basically have this chord that is going over the pulley. And this chord shouldn't be extensive, meaning that it shouldn't extend. And then also, or it shouldn't be elastic. That's how you could think about it. So also it should be massless, meaning that we don't want to consider the mass of the chord, because then it becomes a different problem, because now it has weight and all of those type of things. All right, so in that way, at least we know that we have the same tension throughout. So it has the same mass throughout. Or it doesn't have any mass, it's massless. So, and then it doesn't stretch basically as well. And then also you have to assume that in the pulley there's no friction and the pulley itself doesn't have mass. So that takes away the mass, that takes away the weight, and it also takes away the friction that we'll have to consider here. So we don't want to complicate this problem. So generally, it should be a very simplified version of this problem. So what you expect is you expect then that there's going to be a tension force here, and you expect also that there's going to be a tension force here. And since it's massless and the string is massless and it doesn't basically stretch, the tension is going to be the same. So you won't have T1 and T2. The tension is going to be the same on both sides. All right. So I mean, if you set it up, so you have to use work energy relations to find the kinetic energy, and then you can use Newton's laws to actually find the tension. So let's just start with the kinetic energy one. All right. Now, let's just assume that there's no friction. There could be friction. I mean, there could be problems whereby there's friction. I'll just highlight what you should do if there's friction. All right. So if you look at M1, for instance, how it looks like is it's just going to have the tension force here, and then it's going to have the normal force, and then it's going to have the weight, which is Fg. Then of course there's going to be this parallel, perpendicular component, and then there's going to be this parallel component. All right, and then there's going to be theta here, which is 24. Okay, so we have done this. If there was friction here, then there would be friction this way. friction Fk. All right. So there would be friction that way. All right. If there was friction, maybe let's just include friction. Let's just say the coefficient of kinetic friction when it's sliding is going to slide from here to here. That's going to be that's just basically going to be, let's just make it small. Let's just make it small. Let's just say 1 2 1 2 is fine, or 1 3 is fine. All right, just make it small. All right, this is so that you know there isn't much resistance here. Then if you look at this block M2 here, this block M2 has a tension force going up. There's the tension force, which is this force going up on the string. Then it has weight. So this weight, you expect it to be the one that is actually going to, let's call it F2G, let's call this F1G. So you expect this weight to be actually the force that is going to pull this, if at all it's going to move. All right. And then, so you expect this to accelerate this way, and then this side, you expect it to accelerate this way. So what you do is when you're working out this section here, let me just try and see if I can make space. I can. So when you're doing this section here, have your Cartesian plane like this, choose your X like that, and then choose your Y like that. But then when you're working with M2, have your Cartesian plane like that. So you could have like 2 Cartesian planes. It doesn't matter. It's not a big problem. All right. So you could start with tension first if you want, find the tension, or you could start with finding the energy. Really doesn't matter. So let me just remove this because I want to draw something. All right, so let's just have it here. This is X and then this is Y. All right, so this block is going to fall by some distance. So at least they are telling you that it's going to fall. So they are telling you that the distance, let's call that distance delta S, and that distance is going to be 1.2 meters. Now the question is, as this block is moving down, and then after some time it's here, the question is, what happens to this block? Well, also this block is going to move, but it's going to move up the slope. And then after some time, I don't want it to do that. And then after some time, it's going to be somewhere here. All right. So M1 is going to move. Now the question is by how much? Well, if this moves by 1.2, even this is going to move by 1.2. And the reason that is the case is because the acceleration you expect it to be the same. Both of them, let's just assume that they start from rest. So we're going to have V1 0 here. Then here also is going to be V2 0. Then here is going to be a final velocity. Let's call it V2. Here is going to be the final velocity. Let's call it V1. All right. So it starts with an initial velocity of 0. And then also here starts at rest, which is 0 meters per second. All right, and then it falls down. It will reach this point with the final velocity. As it is actually falling down, it is actually also pulling this object, which is that this object also will have some final velocity here. All right, so that's basically what is going to happen, and then we can actually find the total kinetic energy of this system. All right, now if you want to find the total kinetic energy of this system, basically you need to find the kinetic energy at this point and find the kinetic energy at this point and just basically sum the two. All right, so we'll have to use work energy relations to actually find that. All right, so I'll try and leave some space. So how can we do that? Now using work energy relation on M1, let's just work on M1. If you work on M1, all right, so I have the tension force, so I'm going to have the work done by non-conservative forces. Remember, the non-conservative forces are all the applied forces, the tension forces, and also all those things. And then I'm also going to have work done by gravity. Why? Because if you look at it, it's going to start from here, and then it's going to move some height. After some time, it will have traveled some height, h. Let's call it h1. So I'm not going to find this height. I think it's going to be more difficult. It's not going to be difficult. You could find it because you know theta is going to be this. The angle here is going to be the same as theta. You already know the distance. You could find the height if you want, but I'm not going to do that. I'm going to use this angle differently. Okay. If you want me to use the height, you can just tell me. So this one already, I mean, it's already the height. This one is just for the height. There's no friction. Okay. And then this is going to be equals to change in kinetic energy. Always start, this is the easiest way to actually work the do the work energy problems, you just do it like that. All right, and then it's much more easy like that, and then you just substitute this one with mgh, and then just consider it as a potential energy if you know h. If you don't know h, I'm going to do it the way I'm going to do it. Now here, the work done by non-conservative forces. What are the non-conservative forces? It is this one, which is the friction. It is also this one. So you have to find work done by tension, work done by friction. Then this is just the work done by non-conservative force. These two work done here, basically. And then this is work done by gravity, which is this one. And then this is equals to change in K. So this is where most students get confused, not knowing what is work done by what is conservative, what is non-conservative. All right. Okay, so in this case, you have it like this, and then you can substitute now. If you look at it, since my Cartesian plane is the way I have it, I'm not sure if you guys can see it. You should be able to see it. Okay, so basically what you should have now is you have your t is positive, so work done by t is going to be t, the distance that will be traveled, that t is going to do work over that distance, which is that. Now the cos of the angle between t and the distance is 0. Why? Because t is facing that way, and also delta s is facing that way. So you can see that they are parallel to one another, so which means that theta is going to be 0. So I was supposed to have cos of the angle here, which is 0. So since it's going to be 1, not 0, sorry, it's going to be 1, it's cos of 0 degrees, which is going to be 1. I'm just going to ignore that. Or maybe let's just for clarity's sake, I'm going to let me write everything. Then let's see. Then I have this friction. All right, so just write it as a plus for now. It's going to be this frictional force. It's going to do work against it's going to do work, negative work. All right, and then the reason why it's going to be negative is because if you look at it, the distance is facing that way, the block is moving from this position to that position, so this is delta s, but the frictional force is pointing in that direction. This is Fk. So the angle between the two vectors is 180. So this is going to be cos 180 degrees. So I expect that you would have gone through my work energy notes in order for you to solve this problem. And then after that, let me now erase this. I'm just explaining everything as I go with that. Now we need to find out what is the work done by conservative forces. Now this is, if you knew H, right, this would be the minus of the, this would have been the minus of the potential energy. So you would have said this is going to be minus mg, and then you would say h1, for instance, if you knew what was h1. All right, so anyway, it's going to do negative work in this case because it's going to be positive, it's going up, so it's going to do negative work, meaning that it's doing work against gravity. All right, so since I'm not going to calculate h, right, I am actually going to use this f parallel. Why can I use this f parallel? Because this f perpendicular component is basically the component of gravity, and gravity is the force that is a conservative force. Even this f parallel is the component of gravity, and gravity is a force that is actually conservative. So we don't consider this one because if you look at it, delta S is like this, right? And then you have this one, which is F perpendicular. You can see that this perpendicular to the distance. And when you want work done by F perpendicular, it is going to be F perpendicular, delta S, cos of 90 degrees. And cos of 90 degrees is 0, so this work is going to be 0. So that's why I don't even think about it. I don't even consider it. So which means that I am going to have a situation here. All right, so which means that I am going to have now a situation whereby the only force that is going to do some work is this F parallel. This F parallel is going to do work over delta S because that's a distance that will be covered by M1. And now what is the angle? Now if you look at F parallel is going this way, F parallel is going that way, but delta S is going that way. So again, there's 180 between them. So this is going to be cos of 180 degrees. Okay, Then I'm done finding the work done by tension, which is that, work done by kinetic friction, which is that, work done by this, which is that, and then so I can just say this is going to be the final kinetic energy, which is half mv1 squared, which is this final speed here, minus the initial, which is minus half mv01 squared. All right, so now I can now simplify it further. So tension, I don't know tension, so it's going to be this one, and then this is going to be delta S. This is 1, so I'm not going to write anything. Now remember how you can find friction. You can find friction, meaning that if I know the normal force, then I can find friction. Okay, and then cos of 180 is going to be minus 1. So what's going to happen is it's going to affect this plus here. So I can get rid of this plus and then change it, and then it becomes minus, because cos of 180 is minus 1, and then minus 1 multiplied this positive is negative. Even here, cos of 180 is going to be minus 1, and I already have, sorry, I was supposed to have a plus, not a minus. I left it as a minus because I was still considering the minus potential energy. But if you're not doing it the potential energy way, just do it like this. Just work done by gravity will be given by that. Then the minus is going to come from this one, and then you're going to have a minus. That's why it ends up being minus anyway. All right, and then F parallel, whatever F parallel is, I'm still going to find the normal force in F parallel using Newton's 2, and then this is delta S. And then afterwards, this is just going to be half. In actual fact, let me call this the final kinetic energy. Is going to be easier that way. This half mv squared is just going to be the final kinetic energy. This one is going to be 0 because I'm going to substitute 0 here, and then this is going to be 0, so this is just going to be 0. Okay, so now I need to find out what is going to be Fn, what is going to be this F parallel. So how does it look like, right? I have Fn looks like that, and then I have FG looks like that, and then I have theta here, and then I have F parallel looks like that. Okay, so I can actually find what Fn is. This is F perpendicular. So if I use Newton's 2, so again, you should have watched my Newton's 2 lectures. So I'm taking it that you already know how to do this, right? So if you look at the forces in the, if you're looking at the forces in the y, right, and they are equals to 0, is going to be Fn minus F perpendicular. I'm going to do it, is going to be equals to 0, which means that Fn is going to be equals to F perpendicular. This is not always the case. I mean, I could complicate it. For instance, if I had the tension force at an angle, then you can't say this. It becomes more complex to solve the problem. So in this case, I already know what is F perpendicular. It's just the y component of this, which is going to be m1g. And then this is going to be the cos of theta. Why cos? Because it is adjacent. I mean, if you're looking at it, it is adjacent to this side here, right? It is adjacent. Okay, so it's just next to the angle. And then this one is opposite the angle, so you can use sine. So this is going to be Fn. Okay. All right, and then what about F parallel? Well, F parallel is just the x component of that. So basically F parallel, I don't need to do forces and whatever. I just can get it from here. It's just m1g sine of theta. That's just F parallel. I don't need to do any magic there. All right, so I prefer not substituting numbers first. I prefer working it like this and then substitute numbers at the end. So if you prefer a different method where you substitute numbers, you can do it like that. All right, so okay, now with this one, and then you still have like T delta S minus mu K. I forgot delta S here. Okay, and then this one Fn, I said, is going to be m1g, and then this is cos of theta, which is that 24 degrees, and then minus F parallel is going to be m1 sine of whatever theta is, and then delta S. I keep forgetting delta S here, so let me just make sure I don't forget delta S. This is going to be equals to the kinetic energy, the final kinetic energy. There's nothing much I can do, so this becomes my equation 1. right? So you'll see how it's going to work out at the end. Okay. Now, what about M2? What's happening with M2? Now, remember, M2 looks like this. There's a tension force, and then there is the M2G, which is the force of gravity. That is the one that is actually making this system move. All right. So what you have now is a situation whereby you can then go, you can actually now say the work done here, there's only work done by non-conservative force, which is this, work done by conservative force, which is that, and that is going to be equal to the change in kinetic energy. All right, so how you can do that is work done by non-conservative force. You always start with this equation, work done by conservative force, which is work done by gravity. This is what this work done. Okay, let's just say conservative force are supposed to say G, and then this is going to be equal to change in K for this M2 now. So what is that? That is T, and T is up. And then this is going to cover distance delta X. Now, if you look at T, T is going up like this, but the block is going to go down. So delta X for this one, delta S for this one is going down. So the angle between T and delta S is 180. So this is going to be cos of 180, right? You will be lost if you haven't done my chapter on energy. You have to read my chapter on energy, all right? Or you have to know something about how to solve energy problems in order for you to understand what I'm doing and where I'm getting these equations from. Okay, and then this one, work done by conservative force, which is work done by gravity, is simply going to be the work done by that, which is basically M2G delta S, and then it's both of them are going down, so it's just going to be cos of 0 degrees. By now, I'm hoping you already know how I'm getting this. This is going to be the final kinetic energy because it will start here with kinetic energy 20, and then it will end here with kinetic energy 2. Remember, here it is the speed v2, here it is the speed of v2 0, which is 0 here. All right, so this is going to be the kinetic energy 2 plus the kinetic energy 0, 20, basically. This one is going to be 0. So let me simplify everything. This becomes minus TS and then plus M2GS. And then this is just going to be K2Y because this becomes 0. So I don't have to include it. This one. This becomes 0Y because this value here is 0 meters per second. So when you substitute it here, basically K20 is half M2, so that I don't take it for granted, 20 squared, and this is going to be 0, which is half M2 multiplied by 0 squared. So everything here becomes 0 joules. So that is why I don't do it. That's how I also eliminated it here on top here, if you look at it. Okay, all right, so this is my equation 2. All right, and then now I have equation 1 and equation 2, so let me just write all of them. Okay, I already have equation 2, so let me just write equation 1. Equation 1 is T delta S and then minus mu K, whatever the value is, M1 G, and then cos of theta, which is cos of 24. I'll just say cos of theta for now because I'm not substituting. Delta S minus M1G, and then sine of theta, and then delta S, and then this is basically going to be equals to K1. So this is the final kinetic energy of M1, the final kinetic energy of M2. All right, so if I want to cancel this, I want to cancel T so that I can just get the sum of that. All right, so if I get the sum of that, I have to add the left hand side. I'll have to add them, and then this is going to cancel. This is going to cancel. All right, so I want the total kinetic energy, the final total kinetic energy. So basically I want K2 plus K1. You could say K1 plus K2. It's up to you. It's fine. It doesn't matter. All right, so what am I left with on the left hand side? Now this is going to cancel this. All right, and then I'm left with M2 G delta S. I'm left with this minus mu K M1 G cos of theta delta S minus this one, m1 g sine theta delta s. All right, then that's it, because this one is just k2 plus k1 on the right hand side. So what I did was I took this right hand side and then I put it on the left, and then I took what this was on the left and then I put it on the right. Okay, so basically you can actually find this value because you can substitute every value there, you know. I think let's just go and check the values. All right, so this is what I'm looking for. I'm looking for this total kinetic energy of the system. So this is just going to be equals to, this one is 7, and then you could simplify this further, but I'm not going to do it. It's fine, let's just do that. Enough with maths or algebra. All right, and then now this is 0.13, and then this is I think this was 5, and then 9.8, and then you say cos of 24 degrees, and then this is multiplied by 1.2. I'm just writing it as I said. This is 5, this is 9.8. I should have simplified it, I would be done by now. And then this is sine of 24 degrees, and then multiplied by 1.2. All right, so basically if you do this one, if you get a positive number, it means that the system does go down. If you don't get a positive number, it means that the system actually is false. Basically the question is impossible, it doesn't go down, meaning that you don't have enough weight to actually pull it up. So actually you may be losing energy, kinetic energy, because it could be going downwards. All right, so that's basically how you could interpret it. So hopefully I didn't check if the values are going to add up, so let's just see if they are going to add up. Okay, so I get 51 joules. All right, so just please punch these numbers and just check if you also get that same number. All right, I just rounded it off. It's about 51 joules. Okay, 51.4, so I'm going to leave it as just 51. All right. All right, so this is basically my total kinetic energy. So if you want to find the tension force, you have to use Newton's laws. It's going to be easier. If you try with energy relations, it may be tough with those equations. I haven't tried it, but I suspect so. All right, so let's just use Newton's laws. So what I have is, remember, I have this block. It has the tension force. There's the tension force, and then it has this kinetic friction here. This is m1. All right, now remember that I have this fn, and then I have this fg. So again, you should have watched my lectures on Newton's law. I'm going to link everything in the descriptions below. All right, so that you know what to do, with what to watch. Those lectures are long, so you may have to skip if I haven't partitioned them using timelines, but if I have, then it will be easier. So I haven't done it at the time of this recording, and then I'll do it. It just depends when do you watch this video. All right, and then this one, m2, is going to be g going up, and then m2g, which is fg, this one of fg basically. All right, so I'm taking it, we already know what is fn, we already know what is f parallel, f perpendicular, we already know what is f parallel. I've done it on top, so we already found it. So we know that if we sum all the forces in the x, we are going to get minus fk, and then plus t, and basically this is going to be m1a. All right, so we're assuming that it's going to move up. We know that it's going to move up because we found the positive energy, so we gained energy when we moved up basically. All right, so this is good. I think this is all. You just have that friction, oh, plus this one, nearly made a mistake, so plus this one, but then it's going that way, so it's going to be minus f parallel. Then this is basically going to be m1a, All right, so I have to find this acceleration one way or the other. Otherwise, I don't think it's going to be possible to find t without this acceleration. All right, you can substitute this. I mean, this is, you already know this is mu k. Let's start with mu k. This is going to be mu k m1 g. And remember, this is going to be fn, and then cos of theta, whatever theta is, plus t minus this one is m1g sine of theta, okay, whatever theta is, and then this is m1a. Right, for this one, it's just going to be t minus m2g is going to be m2a, but because it's going down, it's going to be minus. So you please don't forget the minus. I don't know why it's not writing the minus. Oh, there is a minus. All right, there's supposed to be a minus here. Just take it as a minus here. All right. So what you want to do is, since you have p is positive in all of them, so what you want to do is just to subtract these two equations. Call this equation 3 because we already have equation 1 and 2. Call this equation 4. So what you want to do is you just want to take equation 3 and then you subtract equation 4. I'm hoping you know how to do simultaneous equations. If you don't know how to do simultaneous equations, alternatively you can substitute. You can just say t is going to be equals to m2g minus m2a, and then take that value. If you want, you could do it like this, take it and then you substitute it on equation number 3. I prefer to do it like this. You are still doing the same thing effectively. All right, you more or less, you're still doing the same thing. All right, so this becomes minus, this becomes plus, and then this becomes plus in this case. All right, so when you do that, you having this mu k m1 g and then cos of theta. Then since this is going to be plus and then this is going to be minus from this equation, it's going to cancel. This is going to be plus minus this one is going to cancel. And then you are left with this one, m1 g sine of theta. And then this is going to be plus because remember you're minusing, so it's going to be minus, so it's going to be a plus. I'm really hoping that you guys know how to do simultaneous equation. I'm going to do videos on maths from now on as well, so I'll teach you how to do simultaneous equation. Okay, maybe it's the first math video that I have to make because I use this a lot. Okay, and then afterwards this is m1a and then plus m2a, not ga. Okay, so from this you can actually find what a is going to be. So a is going to be equals to, the reason why I prefer doing it like this, because it's possible that you could be asked to show that maybe like acceleration is given by this equation. So this is how you actually work these things out. So I wouldn't recommend that you, I know students like plugging in numbers. It's easier when you do it like that, of course. But I prefer this way. You practice your maths. You can also just answer different scenarios. This is m1g cos of theta and then minus m1g sine of theta plus m2g. Now here, this is going to come out. I mean, if you're looking at this, this is m1. This is the same as you take out a, you are left with m1, you are left with m2. So what you do is you divide both sides by m1 plus m2, and then you divide both sides, this side and this side, and then you are left with a only here, and then you are left with everything here is going to be divided by m1 plus m2. That's basically how it is. Okay, so I'm hoping that you can do this. You know how to do this, how to factor things out. And then I'll start doing maths videos where I'm teaching you and then we're just revising these concepts. I'm just gonna do short videos from now on. I'm no longer gonna do videos that are like hours. Okay, and then after this, you can just find whatever the acceleration is. There's a, and then basically you just say minus 0,13 multiplied by, again, I could do things easier here. For instance, I could take out this 9.8. Maybe I should do that. It's going to be easy. Okay, let me not confuse you. Let me not confuse you. So this is going to be 5 multiplied by 9.8 cos of 24. If it's not 24 degrees, I'll change it to 24 because I've already worked with 24. I have to check if I said this is going to be 24. I think I said it's going to be 24. 9.8 sine of 24 degrees. This is multiplied by, and then here I have m2, which is 7 multiplied by 9.8. All right, so you expect these values to be smaller because of cos and sine is going to reduce these values. So this 7 times 9.8 should actually leave these values a little bit larger, and then this is just divided by 5 plus 7. Right, and then you punch that on your calculator. Okay, so this should be plus. I don't know why there's a delay. So I get a very 3.6 meters per second squared. That's my acceleration. Then afterwards, I can take this acceleration and then find the tension force. Remember, there was equation 1, equation 2. The easiest equation I could use was equation, not equation 1 and 2, 3 and 4. So the easiest one is equation 4, which said T m2g was going to be equals to minus m2a. So it's easy, I just take this one, I substitute. Now, if you got a negative a here, it means that your assumption that it was going to move to the right is actually incorrect. It's actually moving in the opposite direction. But since you get a positive number, it means that your assumptions are actually correct. The system is going to move. M1 is going to move to the right, M2 is going to move down. Otherwise, if you get a negative, it means M2 is going up and M1 is going to the left. That's basically what how you can actually interpret this. So it's very important that you interpret these type of scenarios, all right? Because just to make sure that you understand. So here T is just going to be equals to M2G minus M2A, which is going to be 7. I'm just going to take out the 7 because it's common. I'll probably do a video this week on maths showing you these things so that it makes life easier for you guys. And then 7 because it's common, and then you're left with G, which is 9.8 minus 3.6, I think. All right, and then basically this is your T, and whatever T you get here, you should get the same T even if you use equation number 1. If you don't, you have to check what mistakes did you actually do or did you do. Right, it just depends. You should get the same. I didn't check, I won't check, but you should get the same. Then basically our tension force is 43.4 Newton. All right, so this problem is very nice because it involves Newton's tool. You get to do inclined planes, you get to do energy in inclined planes as well. So you combine. So I personally like questions like this when I'm testing my students. And some students don't like it. It just depends. So pulleys, so you got to work with tension, pulleys, energy, and everything else, and which is actually quite good. All right, so I just wanted to solve a question like this. I thought it was very interesting, and I'm going to do sort of questions that are like this. Please send me emails as well, and then I help you with your questions and see. Sometimes I may be able to do a video. Sometimes I may just respond on your email if I have time. All of this is dependent. If I have time, I hardly have it. So please bear in mind that is also a possibility. All right, otherwise guys, I think this is a great video. I'll see you guys whenever I upload a video. All right, cheers.